All right, y'all should have 3 things in front of you to be able to complete the notes with. I'm going to try and go through it thoroughly but quickly. So remember that you can pause and rewind, but I don't know that everybody needs me to go quite as slow. So this one is going to go on page 116, and I did tell you that I was going to make this from home. I'm sorry, no, I said I was going to make it at school. Probably shouldn't have said that because I couldn't stay late enough Monday or Tuesday to get it done. So I was forced to do it at home, which means handwriting is way worse, and who knows what weird thing is going to happen with my tablet while I'm trying to get this done. Okay, so on Monday, when we graphed, I showed you how to sketch in the parent function so that you could then look at the transformations that were happening in the equation and just move it along with it. So that is a perfectly fine way to do it. Sometimes that's easier than others depending on what kind of translations and whatnot you have. So another way you can do it is by looking strictly at the points, at some of the ordered pairs, and just going ahead and plotting those. One thing that you're going to have to do as these get a little bit more tricky is also pay attention to the domain or how you are labeling your x-axis. So here pi halves is right here, but it's 3 spaces from 0. You could make it 4 spaces from 0 or 5 or whatever works for you depending on which or what's going on in your transformation. So I went ahead and I left these on here because we could adjust them, but really this one I don't think needs adjusting. I think the way it is fine, and that's something that you need to be able to understand from a graph as well. So let's look, before we graph anything, we're not actually going to graph the parent function on the graph. You do, of course, have to have an idea of what sine of x looks like. So sine of x is going to look something like this, right? Well, we got these key points right here. Okay, so I'm using the stylus where I can actually make a point, but it still doesn't make it very well. So sine of x looks something like that. So if this is what I want to actually graph down here, we're going to start with y equals sine of x. And we're going to look at the points for the parent function, but not actually graph it. I just did that so we had something to look at here. So we know that the normal period for sine of x is 2 pi. And when you graph in the parent function, this is really starting here at 0, 0. So at the origin, our point is, okay, the other bad thing about this pen is it's hard to make curves sometimes. There we go. 0, 0. And then the period is 2 pi, and we're going to end up here. So we go, the x value would be 2 pi at the end of the period. And then the y value is 0 again. So halfway, half of the period, the y value is 0 again, but halfway, here's where I messed things up the other day. Half of 2 pi is pi. And the y value is 0. So this point right here, we know that y value is 1, and this is pi halves 1. Although you should know what goes here. I want you to think about it this way with the fractions, because I know y'all don't love fractions, but you have to have a way to think through things. If I go from 0 to pi halves, this is really 2 pi halves, which is just pi. So then this is 3 pi halves. And that is at -1. And that's 4 pi halves, which is 2 pi. That's also 0, 90, 180, 270, and 360. All right, so when we look at it point by point here, we want to look at what's happening to the x and what's happening to the y. So here, I do have something, if this was just sine of x, nothing's happening with x, but there's a 4 times x. Remember, whatever's happening with x in the function that you see, the x lies, so you do the opposite. So what you do with this x value is, instead of multiplying by 4, you actually divide by 4. Well, 0 divided by anything is still just 0. And then the y value is what happens here. This is a reflection in the x-axis because this just changes the sign on the y value, which still makes that 0. So that was very uneventful. But then when we move on, we've got pi halves. Okay, that's my x value. I'm supposed to take that and I'm supposed to divide by 4. So dividing by 4 is the same thing as multiplying by 1/4. So 1/4 times pi halves is pi eighths. And then the 1 is my y value. That gets a sign change. I get -1. Move on here. Pi gets divided by 4, so that's pi fourths. And then 0 is still just 0. Then we've gotten 3 pi halves. We're going to divide that by 4, which is the same as multiplying by 1/4. So this is 3 pi eighths. And then that -1 becomes a +1. 2 pi gets divided by 4, so that's 2 pi fourths, which is really pi halves. And 0 is still 0. Okay, so basically these are my new points for my new function. But let's also look at what's happening here. Our amplitude is 1. We have a reflection in the x-axis. Our period goes from 2 pi to find the period by taking the normal period and dividing it by the b value here, the absolute value of that. So 2 pi divided by 4 is pi halves. So your new period here is pi halves. And that should make sense because we go from 0 to pi halves. This 4, remember that's the number of cycles. So that's how many times this shape right here is going to repeat itself in a 2 pi window. Okay. So then we're going to go down here and go ahead and we can just plot these points. Plot our new points right here. And so I have 1 at 0, 0. So I have pi eighths, -1. Now this is pi halves, and then, we're dividing by 3 here. So another way to look at this, when you can go from here to here, the beginning of my period is at 0, 0. The end is at pi halves 0, right there. So I've taken care of these two. Now I go to the one in the middle, that's pi fourths. It has to be in the middle of these two, so bam, that's right there at 0. Then this pi eighths is halfway between 0 and pi fourths. So halfway between that would be right about there, and that's at -1. And then halfway between these would be right here, and that's at 1. So there is my 1 cycle. Now, remember, me trying to do a curve with this pen, I don't know. Oh, it's going to look shaky like a... Yeesh. Maybe it would be better if I did it dotted. I don't know. Okay, something close to that. So now that we get this, then we're going to repeat it. Well, as you repeat it, when you look at your graph, look, we're going from 0 to pi fourths. And then this is another length of pi fourths. So that's 1.5 spaces on my graph. So every 1.5 spaces, my y value is at 0. So I can go ahead and fill all those in. So it goes to there, and then at pi. Because if pi halves is 1 cycle, then to pi will be the second cycle. And then there and there. There and there. So then, it's going to continue this pattern here because it's a periodic function. So this is going to be down here, and then up here, and you just continue graphing. And so on all of these, you're going to have to fill in the whole graph. I'm just going to do this much right now so we can look at what's happening. Okay. Yeesh, I was better off at the beginning. Okay, so when we look at this, remember that 4 is the cycle. So that is 1 cycle, 2 cycles, 3 cycles, 4 cycles from 0 to 2 pi. And my period is just pi halves because every pi halves, it's going to repeat. So then again, I need to finish out my my graph here. Oh, dang it, it's doing so well. So this comes down here, and then back up here, and then back down here. All right, so then here, still every 1.5 on my x-axis, I'm at 0. All right, and then halfway between these two, here, and then halfway between these two, here, and then I'm just going to continue. Making sure that when you go to 1, you're actually going 2 spaces up because of the way it is labeled. When you're trying to just repeat, it's easy to get something a little wonky just because you're not paying attention. Okay, so I'm sketching mine in kind of quickly because mine's not going to look good no matter what I do. If I was doing this on paper, I'd be a little slower and a little more careful. I expect yours to look like you at least attempted to do this the right way and didn't just slop it on there. Well, pretend like that's curvy. And there you go. That is y equals negative sine of 4x using the points. So let's look at the next one. Cosine. Okay, so remember cosine looks like this, but a whole lot better. All right, so my parent function, y equals cosine of x, origin. That doesn't mean that it's always going to be 0, 0. It means at the origin or when x is 0. When x is 0, y is 1 for cosine. Then we go to pi halves. And at pi halves, I am at 0. At pi, I am at negative 1. At 3 pi halves, I am at 0 again. And then at 2 pi, I am at 1. Okay. So now I look at what's happening with my x and what's happening with my y. My x value right here is being multiplied by 1/2, which means I'm really being multiplied by 2 because it's really being divided by 1/2, which is multiplying by 2. So 2 times 0 is still just 0. My y value is being multiplied by 4, so that becomes a 4. Then pi halves is going to be multiplied by 2, so 2 times pi halves is just pi. And then 0 gets multiplied by 4, and that's just 0. Pi gets multiplied by 2, so it's 2 pi. And negative 1 gets multiplied by 4, so it's a negative 4. 3 pi halves multiplied by 2, so that's 3 pi. 0 times 4 is 0. And then 2 pi gets multiplied by 2, so this is 4 pi. And then 1 times 4 is 4. So I want you to notice on these x values, we go from 0 to pi, so it goes up another pi, goes up pi, goes up pi. The difference is the same there because these are periodic functions that actually repeat. Even though you can squish the graph together and stretch it out, it's always going to be squished together uniformly. It's not going to be like part of it's squished together and part of it's not. Not when they look like this anyway. If we start dividing and doing some other things in there, then things like that can happen. But when you're looking at just the ones that we're doing right now, you're going to have a pattern in your x's like that. Alrighty. So we're going to come down here and we're going to graph it, but we're also going to look at what's happening again. Remember that this is your number of cycles. So when you go from 0 to 2 pi, which is our normal cycle for cosine, from 0 to 2 pi, you're only going to get half a cycle in, because one full cycle goes from 0 to 4 pi. So here would be at 2 pi, that's only halfway through your cosine cycle. And that means that's why your period is 4 pi, because every 4 pi you're going to repeat this cosine. This 4 is your amplitude. So there's not a vertical shift here, since I'm not shifting up and down. The x-axis is your midline, which means you're going to go up to 4 on y and down to -4 as well. All right, so I've already spaced these out a little bit for you, because on the last graph, this was pi halves. Okay, so we could do that, except it's just not going to work out too nicely, because we wouldn't be able to finish this off. So we're going to go from 0 to 2 pi and that much, and then you can label the rest if you want. But all right, so we're going to plot these points. 0, 4, so this is 1. Pay attention to how it's numbered. That's 1, this is 2, 3, 4, all the way up here. At pi, we're at 0. At 2 pi, I am at -4. Then at 3 pi, so I do need to make sure that I'm doing this correctly. So 1, 2, 3, and I get pi. 1, 2, 3, I get 2 pi. So 1, 2, 3, I get 3 pi. And then 1, 2, 3, I get 4 pi. Let's go ahead and label that much. Otherwise, I'm likely to plot something wrong. So at 3 pi, we were back at 0. And then at 4 pi, we were at 4. Okay. And then this is going to give me 1 cycle of my cosine. So that is not great, but it is way better than I expected it to be. And there's your 1 cycle of cosine. So then we're just going to repeat this. So we got 1, 2, 3, that's at 5 pi. We'd be back down at 0. It should be curvier than that. I'm not even going to try it with this pen, but if I had a pencil or if I was on the board, it would maybe look better. I don't know. Then, so if I'm up here, 0, 4, then at -pi, I'm going to be back at 0. Then at 2 pi, I'm going to be at -4. Then at 1, 2, 3, -3 pi, I'm going to be back at 0. And then at -4 pi, up here at 4, back at 0. And there you go. So our amplitude is 4, because from the x-axis, or the midline, which is the midline in this graph here, to the maximum point is 4. And then the other way to look at the amplitude is from max to min. It's half that distance, the vertical distance of the graph. And then we get 1 cycle in a 4 pi domain. And then 2 pi, we only get half the cycle. Okay. All right, next one. This is going to be y equals sine of x. So our origin for sine is 0, 0. Then we get pi halves. And 1. We get pi, 0, 3 pi halves, -1, and 2 pi, 0. And on this one, we're going to actually adjust this just a little bit. because we haven't had one on here that has a horizontal shift on it, and I want you to have an example with that. And I had already had these printed out. So we're going to adjust this question. I want you to make this 3 sine of, open my parentheses here, open my parentheses, it's going to be 3x minus pi. Okay. So before I can do any of this, I have to factor out that 3. Okay, so we are going to, I'm going to rewrite that. And y equals 3 times the sine of 3 times x minus pi thirds. Because until it's factored, like if you don't factor it, our transformation rules aren't going to work. There you go. All right, so now I go back in here, my x value. Now 2 things are happening to x, right? I have a horizontal shift and I have a horizontal, is that stretch or compression? Is a compression, because remember you do the opposite for x. Okay? So when I look at x, of course it's not necessarily going to matter with our 0 for all that, but we do the order of operations. So we're going to take 0, we're going to divide it by 3, which is 0, and then we're going to add the pi thirds, because remember you do the opposite. So 0 plus pi thirds is pi thirds. And then for the y value, the y gets multiplied by 3. There is no vertical shift. So 0 times 3 is just 0. Okay, so then we move on to pi halves. So I'm going to take pi halves. I'm going to divide it by 3, which is the same as multiplying by 1/3. So that gives me pi sixths. Then I need to take pi sixths, and I need to add pi thirds to it. Okay, so when I do that, I need a common denominator. So this is really pi sixths plus 2 pi sixths, which gives me 3 pi sixths. And then that reduces to pi halves, which might make you think, what the heck? That's what I started with. But sometimes that happens. And then I take my y value, and it gets multiplied by 3. So it's 3. Then I'm going to take pi. I'm going to divide it by 3. That gives me pi thirds. I add another pi thirds, so that gives me 2 pi thirds. My 0, which is my y value, gets multiplied by 3, and that is 0. Then I get 3 pi halves. I'm going to divide it by 3, same as multiplying by 1/3. So that gives me 3 pi sixths, and 3 pi sixths is pi halves. I'll take pi halves and add pi thirds to it. My common denominator would be 6, so that would be 3 pi sixths plus 2 pi sixths is going to give me 5 pi sixths. And then my y value multiplied by 3 gives me a negative 3. 2 pi divided by 3 is 2 pi thirds. Then I'm going to add a third to it, which gives me 3 pi thirds, which is just pi. And then 0 times 3 is 0. So my period here is 2 pi thirds. Though it doesn't really look like it because it goes from pi, but we didn't start there at 0. So my period is 2 pi thirds. I'm going to get 3 cycles within a 2 pi window. That doesn't necessarily mean from 0 to 2 pi. It's just within a 2 pi domain. And when we did these the other day, we went in there and, plotted our parent function and then looked at it point by point. Basically, we're doing the points before we even look at the graph. But it's important to understand both of them. I feel like if we only focused on doing it this way, then you don't get the idea of how easy it is just to move the graph sometimes. All right, so we're going to go and graph this. When we graph this, I get pi halves. I'm sorry, pi thirds. So I got to figure out where would pi thirds be. So think about the unit circle. Well, just the first quadrant might be easier to look at. So on your unit circle, this is 0, this is pi halves, right? We're not going to label all that, but halfway is pi fourths. Then you've got the pi sixths and pi thirds, right? Because it goes 0, pi sixths, pi fourths, pi thirds, pi halves. So pi thirds is 2/3 of the way to pi halves. We'll look at this. This is counting by threes. So this is pi sixths, pi thirds, pi halves. It's like 30, 60, 90. So when I need this pi thirds, that is 60. That is right here at 0. There is my point. Okay. Then I've got pi halves and 3. So I'm going to count this off to do this right. 1, 2, 3. All right, so at pi halves, I am at 3. It's 2 pi thirds. All right, so 2 pi thirds is right around over here. So that's like another 60, right? So this is 30, 60, 90, 120, which is 2 pi thirds. We're back down here at 0. Then 5 pi sixths negative 3. Okay, you should know where 5 pi sixths is. That's 30 before you get to 90. I'm sorry, 30 before you get to 180. Plus, if you notice the spacing here, remember how I said this is being compressed together, but it gets compressed evenly. So if I'm going every other hash mark here to be able to graph something, when I come back down here, let me make sure I count right. This is 1, 2, 3. Then I'm going to be down here. That has to be 5 pi sixths, which it is. And then at pi, we're back at 0. So this is one cycle that I know is going to look too pointy when I try and draw it. But, I know a lot of time is wasted on this video on me having to redraw stupid things. Okay, so there is one cycle. Right? One cycle, and your period is, we take 2 pi and divide it by 3, so it's 2 pi thirds. That is 2 pi thirds from here to here. Then I'm just going to repeat my graph because it is periodic, so I can tell where my zeros are. The other one. I want you to wow me with your graphs. Show me how much better they look than mine. Mine on paper don't look too bad. Then this is up here. Then I'm down here. And when you're doing this, be careful not to do it too quickly, and then you just get off on your counting. From here. All right. There's probably some tool on this thing I can make nice curves, but this is a sad looking graph. Okay, let me just say this. If you try to give me some junk like this, I'm not taking this stuff. If I had more time, right now I could try and make these better, but I think you understand how to graph it. And I can show you my paper ones if necessary. Dang it. Okay, I'm going to pretend like that one's in there. Oh my gosh. This should be way curvier. It's just hard because I didn't lift my pen. It's going to erase all of it. So like that, but a whole lot better. Okay, so that is the first set. All right, now I want you to grab the pink notes that look like this. And this is, we're not graphing these, we're just looking at algebraically what happens to the point, which is basically what we did in those little charts on the ones we just graphed. So I'm giving you this 1 point. So this 1 point that it says the given parent graph point, so that would be a parent graph point, would become what point under the transformation indicated in the equation. Oh, and I know yours has like a name and a period up there, but you can just change that to ISN number or whatever it's going to go on 117 because this is just part of your notes. So just like we did in that little chart, I'm going to get an ordered pair and I'm looking at what happens with x and what happens with my y. So with this pi over 2, that's my x value. The only thing that's happening with x, that's a horizontal translation, so I'm going to have to subtract pi sixths. So when I have pi halves minus pi sixths, I need a common denominator. So that's like 3 pi sixths minus pi sixths is 2 pi sixths, which is pi thirds. Then my y value, there's no translation, but there is a reflection and the amplitude is 3, but basically I'm just taking my y and multiplying it by -3. So I get -3, and it's that easy. So when I get to this one, cannot make a curve. All right, so my 0 gets divided by 3, but it doesn't really matter because it's 0, so x is still 0. The y, now I do have a vertical translation here, but you got to do order of operations, so you got to do the multiplying and dividing first. And so I'm going to change the sign because it is a reflection. The amplitude is 1, so I get -1, and then I have to subtract 2, which is going to give me -3 from my y value. Here I've got x right here is being multiplied by 0.5, which is 1/2. So really what I do with this x value is I divide it by 1/2, which is the same as multiplying by 2. So this is 2 pi. My y value, I have an amplitude of 2 and a vertical shift of 1. You got to take care of the amplitude first. So -1 times 2 is -2, and then plus 1 gives me -1. Okay. I got a lot going on this one. Got my x value, 3 pi halves. So, and I have this here. Well, before I can take care of anything in here, I need to factor it. So this is going to become y equals 0.5 times the sine of 3 times x minus pi thirds. Minus 0.5. Okay, I just erased it and rewrote it so it wasn't on the way down here. All right, so I'm going to take my x value, which is 3 pi halves. The first thing I do is divide it by 3. And 3 pi halves divided by 3 is just pi halves. So I've got the 3 pi halves divided by 3 gives me pi halves, and then I'm going to have to add pi thirds. So pi halves plus pi thirds. So I got to get my common denominator. So that would be really 3 pi sixths plus 2 pi sixths gives me 5 pi sixths. Very hard for me to say. And then I'm going to take my y value, which is -1. The first thing that happens is it gets multiplied by 0.5, so I get -0.5. And then I subtract 0.5, so that's going to give me -1. On this one, I don't have anything I need to factor out, so I take my x value, I divide it by 2. Oh, no, I'm sorry, y'all's is different. Okay, I just double checked that nothing else was different. Sometimes my digital copies are different than the paper copies I get, so what yours says, we'll go with what yours says, so it's not too confusing. This doesn't say 2x right here. This instead on yours says x. I'm just going to write the whole thing. Yours says y equals -2 times the cosine of x over 2. Okay, so what's happening here is x is being divided by 2, which means I do the opposite, which is multiply by 2. So my x value is pi, and then pi times 2 is 2 pi. My y value is -1, gets multiplied by the -2, and you get a +2. Okay, so that's how simple it is to do it point by point. So when you are graphing them, whether you're doing it point by point or you are using the parent function to get the shape, either one is fine, but just the shape is not okay. You still have to have some key points graphed, and I think you'll get the hang of, which way would be easier depending on which problems you're using. Okay, so now I want you to get the last half sheet you have, which is like this, 118. This won't take us long to go through. Now we're going to find the amplitude and the period, and then also write the equations for these. Now, these pictures kind of leave something to be, a little bit to be desired here. And it looks like they kind of get cut off, but if you notice that square isn't full there, so it really does go all the way to the next little dotted line. Same thing up here at the top, it kind of gets cut off. And then even on the axis here, the labeling looks kind of weird, like you can't tell if the 1 pi is on the dotted line or what, but what this is really showing you is that is 1 pi, that is 2 pi. That right there where it's 0, 0, this is -1 pi. It's not right on the hash marks, and then this is -2 pi. So my amplitude, and oh, that's right, and I remember I think your writing is kind of small. So this is, I'll rewrite it in there. This is pi, this is 2 pi, and it's at the point where it crosses the axis. This is 0, obviously, so this is -pi, and this is -2 pi. I know those numbers are super duper tiny on there. And then this says 2. So I'm at 1, 2, 3, 4 to get to 2. So every 2 is 1. So this is 1, 2, 3. Then this is 4 up here. That isn't kind of the full square, but we'll pretend like it's there. Okay, so my amplitude is half the distance, the vertical distance of the graph. So I go all the way up here to 4 and down here to -4. So half of that is 4. The midline is here on the axis, so it's also the distance from the midline to a maximum or minimum. So my amplitude is 4. Then the period, okay, so the cycle, one cycle takes me from 0, follow this up and back down, to pi. So my period is pi. Okay. And then I need to write my equation. There is no shift left or right, and there is no horizontal compression. So since I'm starting here at 0, this is a sine curve. So y equals, my amplitude is 4 times the sine of 2x. Oh, shouldn't just give you that. Let's figure out how do we know that that is 2? Well, we know how to find the period. To find the period, you take the normal period for sine, which is 2 pi, and you divide it by b, and that equals your period, which happens to be pi. So if 2 pi divided by b equals pi, then 2 pi divided by pi is equal to b. That gives me 2, and this is my b value right there. Okay. Now let's look at this next one. And I'm not so sure how well you can see the numbers on what you have. But this is obviously 0. This is here at 2. That's what that says. Then this is 5 pi, 10 pi. This is pointing to 12 pi, which is the x value for this point. It's not pointing very well, but that's what it's pointing to, so that you would know that that's at 12 pi. All right, well, I don't even see a full cycle on here. But if I'm starting here at the origin, then my graph starts this way. It looks like a cosine curve, right? So when it gets to here, I'm halfway. So if I keep going to get the full cycle in, that would be twice as much as this. So that would be 24 pi. Okay, so my period is 24 pi. I want you to think about this. Could I have started here and done sine instead and then I'd be writing a sine equation and not a cosine equation. Then they would look different. But remember, a cosine curve is a sinusoidal wave. All it is just translated over a little bit. So, but for purposes of us writing equations, we're going to try and start at the origin to write them. It wouldn't necessarily be wrong, but it would be very confusing if we were all writing different things. But yes, we could totally write this as a sine equation. We're going to use cosine. So my amplitude. There's not a shift because this distance here, oh, I don't know if you can read it, but that's a -2. Okay, so this goes from -2 and this is up here at 2, which means my amplitude is the distance from the midline, and it is just 2. Okay. So I know that this is y equals, the amplitude is 2, and we are using cosine. And I have to know what I'm going to multiply by x. Okay, how many cycles do I get in a 2 pi window? So 2 pi is going to be like right in here somewhere. I don't get very much of one, right? But remember, this is how we can look at this, is that if, I guess I'm going to kind of do it sideways, I don't have a lot of room, that to find the cycle, it would be 2 pi divided by b, or really the absolute value of b. 2 pi divided by b, that would equal 24 pi. Well then, if that's true, then that means that 2 pi divided by 24 pi has to equal b. So then we cancel those pi's out, and 2 over 24 reduces to 1/12. So your b, or how many cycles you get, is 1/12. And it'll be x, because we're using radians. That is how you write those equations. Okay, so I know this was kind of long, but hopefully you get the hang of it. I will answer any questions that you have tomorrow, but that means you got to actually do this stuff and come with questions tomorrow. We're really supposed to test on Friday, but don't freak out. We're not going to test on Friday. We're probably going to test on Monday, though. So I want you to, be prepared for that. We might test. I don't want to test you on Friday, but I'm going to give you a review, and if I may end up shortening the test, and then maybe we'll go ahead and do it on Friday, but we'll talk about that tomorrow. I'll kind of gauge where y'all are. I know I haven't even been able to give you quizzes because these weeks have been crazy already, but I'll make sure that you understand it, but you got to ask me questions if you have questions, okay? But there is one thing that I want to point out to you on the homework. You can sketch the parent functions and do it like we did on Monday, but you can also do kind of like we did on the charts on the homework. Now, on the notes. Now on the notes, I did them like separate ordered pairs, but you can make a t-chart as well. So I could do X, Y, and then think, okay, have your little t-charts of your parent functions handy. Either write them on here, I know there's not a lot of space, or the ones we wrote down in the notes so that you have what they are. So we know if it's cosine, we're starting at 0, 1. So your x value is 0, and make sure you factor this out and do your thing, and you can adjust it and just come up with your chart before you ever graph. That is a good thing to do, so you can make sure you can label your axis correctly, because although on the homework that was due today, you labeling the axis the same every single time works. It works on here, but it's sometimes going to be really hard for you to be able to find where those points are. So think about what would make sense to be able to make your labels on your x-axis. Okay, do your best. Remember, you can go see Miss Tremont if you can find her, Mrs. Archer or Mrs. Rice if you have questions when I am not there. And I should be there tomorrow, I hope.